Okay, this is the summary for Lesson 2, Graphs of Proportional Relationships. So we have two tanks, Tank A and Tank B, both filling with water, but they're filling at different constant rates. And the reason I know that it's a constant rate for each of these is that both of these graphs are straight lines, meaning that they fill a certain amount, a constant amount for each constant unit of time. So if you go out a certain unit of time, no matter what that unit is, it will fill the same amount for each of those units. So go out 1 unit in time, that's 1 minute, it fills this amount, whatever that might be. Go out another minute, it fills this amount, whatever that might be. If you look at, looking for some place where A crosses the grid line, way down here it looks like. Anyway, the point's the same. If I go out the 1 unit, it's going to fill the same amount, a constant amount. Go out another equal unit, it's going to fill a constant amount. So constant rate means it fills at a constant amount of water for every unit of time. And so what is that unit? In this case, what's the easiest unit to work with? It's 1 minute. So tank A fills 2 2/10 liters in 1 minute. So here's 1 minute. And so you go up to tank A and it fills 2 2/10 liters in that 1 minute. So 2 minutes is going to fill 4 4/10. We'll look at that in just a second. But if I go out to 2 minutes, this is going to go up to 4 4/10. 3 minutes is going to be 3 times 2 2/10. So 3 minutes would be 3 times 2 2/10, or 6 6/10. 4 is 8 8/10. So for every minute, it fills 2 2/10 liters. On the other hand, tank B is actually filling faster. So in 1 minute, tank B fills 2 7/5 liters. So in 2 minutes, tank B would fill 2 times 2 7/5, which is 5.5 liters. So it'd be 2 times 2 7/5. So notice that for tank A, the vertical measure, the number of liters, is 2 2/10 times the horizontal measure. So this is 1 unit. So it's 2 2/10 of 1 unit, or 2 2/10. Tank B fills, the vertical measure for tank B is 2 7/5 for every 1 minute. So it's 2, so the slope, the measure in the vertical direction is 2 7/5 units for every 1 unit in the horizontal direction. So every 1 minute in the horizontal direction, this is 2 7/5 times that 1. So that goes back to what we've done for a long time now, is the ratio of the vertical measure to the horizontal measure is the slope. So 2 2/10 to 1 is the slope. 2 7/5 to 1 is the slope. It's the ratio of the vertical measure, this measurement right here, to this horizontal measurement. And it makes it easy in this case because it's 1 unit. All right, so if we go out to 2 minutes, tank A fills to 4 4/10 liters. So 2 times 2 2/10 is 4 4/10. And 2 times 2 7/5 for tank B is 5.5 liters. But what if we want to measure 110 liters? This graph, you can't look at it on this graph. You have to expand the scales. And that was the other part of this lesson, is looking at different scales. So if we expand this scale, so this is the original graph. This graph right here goes out to 10 minutes and up to 10 liters. So way down here, this goes out to 10 minutes and up to 10 liters. So now we've expanded the horizontal scale, the x scale, times 10. So this now goes out to 100 minutes. And we've expanded the vertical scale actually farther, times 15. So this goes up to 150 liters. So now we can look and see what happens at 110 liters. So if you have a volume of 110 liters in tank B, that takes 40 minutes. So you go to 110 liters, you read across to its graph, and then read down, and that tells you that it takes 40 minutes to fill 110 liters. But tank A is filling slower, so that same 110 liters takes longer. It takes 50 minutes, so it takes 10 minutes longer to fill to 110 liters. So let's zoom in on that just for a second. So tank B, once again, fills 110 liters in 40 minutes. If you went down all the way down to the x-axis, you'd see that's 40 minutes. And tank A takes 10 minutes longer. So this is the 10 minutes right here on the x-axis to fill 110 liters. And so that takes 50 minutes. Now notice how much volume is added. So at 40 minutes, tank A is right here. That is 88 liters. At 40 minutes, tank A has 88 liters in it. And so another 10 minutes is 10 times 2 2/10. So it's every minute it fills 2 2/10 liters. What's 10 times 2 2/10? That's 22 liters. So in 10 minutes, from right here, it's going to fill another 22 liters, and it's going to end up at 110 liters total. So the equal amount of volume takes 10 minutes longer for tank A because it's filling slower at a rate of 2 2/10 liters per every minute, whereas tank B is filling at a rate of 2 7/5 liters every minute. So this is the summary. So changing the scales, and looking at two properties for each tank filling. How much time it takes is one property, and how much volume is filled during that period of time is the other property. And then you can begin to look at slope, and then you can compare these two. And again, they fill at a constant rate because they're straight lines. And finally, it is a proportional relationship. If you double the time, you're going to double the volume. If you triple the time, you're going to triple the volume, because these two lines go through zero, and also the ratio of their coordinates. And I'm not going to go into that too much. It's going to come a little bit later. The ratio of their coordinates is the same. So we'll save that for a little bit later. All right, the summary for lesson 2.